So now what are eigenvalues and eigenvectors? So let A be any n row square matrix. We know what is a square matrix, having equal number of rows and columns. So let A be any square matrix of order n, lambda be a scalar, and I be a unit matrix. What is I? Unit matrix means 1 0 0 0 1 0 0 0 1 if it is of order 3. So A is any matrix, any square matrix. Lambda is a scalar. I is a unit matrix of same order. Then the matrix A minus lambda I is called as the characteristic matrix. ठीक है? So what is A? A is any square matrix. Lambda is a scalar, and I is the unit matrix of order of the same order. Then the matrix which is formed by A minus lambda I is called as the characteristic matrix. Determinant of this matrix, the determinant of the matrix A minus lambda I is called as the characteristic polynomial. The matrix A minus lambda I is the characteristic matrix. Determinant of A minus lambda I is called as the characteristic polynomial. And if this polynomial is equal to 0, we say it is an equation. So the equation determinant of A minus lambda I equal to 0 is called as the characteristic equation. Okay? And the roots of this characteristic equations are called as the eigenvalues. The roots of the characteristic equations are called as the eigenvalues, or the characteristic roots, or the characteristic values, or the latent roots or proper values. Okay? So if A is any matrix and I is a unit matrix, then A minus lambda I is called as the characteristic matrix. Characteristic matrix. Determinant of A minus lambda I is called as the characteristic polynomial, and determinant of A minus lambda I equal to 0 is the characteristic equation. And if the roots of this equation are called as the eigenvalues or characteristic roots, or characteristic values or latent roots or proper values. Whole chapter deals with eigenvalues and eigenvectors only. Okay, we have 3 main topics, and there we have everywhere we have to calculate the eigenvalues, and in some cases eigenvectors also. Okay? Then we'll be given a matrix A. We have to form the matrix A minus lambda I, calculate the determinant of of this matrix, and equate that equal to 0. We will be getting a nth degree equation in lambda depending upon the order, and we have to solve that equation to get the eigenvalues. Now suppose lambda is the root of this equation. Suppose lambda is the root of this equation, then we can find a non-zero column matrix X such that matrix A minus lambda I into X equal to 0, then X is called as an eigenvector or latent vector. Okay? If lambda is the root, we find the roots of this equation. We can name it as lambda 1, lambda 2, lambda 3, and so on. So suppose one of the root is lambda. If lambda is the root of this, then we can find a column matrix X such that A minus lambda I into X is equal to 0, then X is called as an eigenvector or latent vector. And always remember that eigenvectors are always a non-zero. We say non-zero column matrix. So eigenvectors are non-zero vectors. That is a very important concept. तो हमको 2 चीज याद रखनी है. एक तो ये है कि आइगन वैल्यू कैसे निकालना है और आइगन वेक्टर कैसे निकालने हैं. To calculate the eigenvalue, we have to calculate determinant of A minus lambda I equal to 0. उसके roots निकालने हैं. जो भी roots होंगे, those roots are called as the eigenvalue. और अगर हमें एक ऐसा x निकालना है in such a way that A minus lambda I into x equal to 0, then this x is called as an eigenvector. Remember, eigenvectors are always non-zero vectors. Clear? Up till here? एनी डाउट इन दिस? बेसिक है, ठीक है. You can unmute B division students because I'm not able to see your chats. No doubt? Okay.
Ma'am.
So let's start solving examples. So take an example 1. Find the eigenvalues and eigenvectors of the matrix A equal to 8 minus 8 minus. So take down this matrix. 4 minus 3 minus 2, 3 minus 4, 1. Find the eigenvalues and eigenvectors of the matrix A is equal to. तो मैंने क्या बोला था? We have to calculate A minus lambda I. तो सबसे पहले हम लोग लिखेंगे A minus lambda I. ठीक है? तो solution स्टार्ट करना है A minus lambda I से. A is given. We know I is a unit matrix. तो हम लोग A की जगह मैट्रिक्स A सब्स्टिट्यूट करेंगे एंड I के बदले यूनिट मैट्रिक्स. सो इक्वल टू A के बदले दिस मैट्रिक्स minus lambda into I matrix. Why we have taken unit matrix of order 3? Because A is a matrix of order 3. जो भी इसका ऑर्डर रहेगा वही ऑर्डर का यूनिट मैट्रिक्स भी हमें चूज करना है. Okay, so A minus lambda I will be this. Now how do we now what happens when we multiply a number by a matrix? क्या होता है? If I multiply a number by a matrix, what happens? All the elements of that matrix will get multiplied by lambda. है ना? When we multiply a matrix by lambda, all the elements of the matrix will get multiplied by lambda. तो क्या होगा? We will have 8, यहाँ पे lambda 0 0 0 lambda 0 0 0 lambda. तो अभी हमको subtract करना है. तो 8 minus lambda into 1, that is 8 minus lambda, minus 8 minus lambda into 0, which is minus 8, minus 2 minus lambda into 0, that is minus 2. So हर एक diagonal element, what will happen? Lambda will be subtracted from each of these diagonal elements because we are having 1 only in the diagonal elements. Rest all the elements are 0. So whenever you calculate A minus lambda I, the diagonal elements or lambda will be subtracted from these diagonal elements. So we will get 8 minus lambda, minus 3 minus lambda and 1 minus lambda. ठीक है? अभी हमें इसका determinant निकालना है. So determinant of this matrix. So determinant of A minus lambda I equal to 0 is called as the characteristic equation. And the roots of this equation are called as the eigenvalues. तो हम इसका determinant निकाल के equate to 0 करेंगे. So what we will write is determinant of this matrix equal to 0. ठीक है? Now if I open this determinant, we know how to open this determinant. If I open this determinant, तो हमें lambda cube का term आएगा because we will get this into this minus 4 into minus 8. So we will get lambda cube वाला term. So when you are having a matrix of order 3, then we can calculate the characteristic equation without expanding this determinant. We have a formula. We have a formula to calculate the characteristic equation without using this determinant part. So and that formula is applied only when you have a 3 by 3 matrix, not for any other matrix. Okay? So the formula goes like this. Lambda cube minus sum of the diagonal elements of A into lambda square plus sum of the minors of the diagonal elements of A into lambda minus determinant of A equal to 0. Now this formula is applied when you have a 3 by 3 matrix. अगर 2 by 2 है या 4 by 4 है तो हमें determinant से ही solve करना है. अगर 3 by 3 है तो you can directly apply this formula to get the characteristic equation. Okay. Now हमें ये नहीं यूज करना है. We have to calculate sum of the diagonal elements of A. Now the diagonal elements of A क्या है? यहाँ पे 8 है, -3 है and 1 है. So we have 3 diagonal elements. So we can add all these 3 elements. So 8 -3 + 1. तो ये वाला ब्रैकेट टर्म हम लोग डायरेक्टली लिख सकते हैं. नेक्स्ट हमें क्या करना है? सम ऑफ द माइनर्स ऑफ द डायगोनल एलिमेंट ऑफ ए. डू यू रिमेंबर व्हाट इज अ माइनर? हाउ डू वी कैलकुलेट अ माइनर ऑफ एन एलिमेंट? किसी को याद है? We had used this in calculating the inverse by using adjoint method. Okay, anyway, I'll explain it again. तो ठीक है, ये फॉर्मूला ले लो एक बार. This is a very easy formula compared to calculating this determinant. It takes time to calculate this determinant and you might make a mistake. But when you use this formula for 3/3, you'll get the characteristic equation easily. Okay? So what we will do is, we have to calculate the minors of the diagonal elements of A. So I'll rewrite this formula again in the next slide. This was the given matrix and we have, this is the formula. Okay? Now, diagonal element we can write directly, 8 -3 + 1. Now we have to calculate the sum. Sum निकालना, किसका sum निकालना है? Minors of the diagonal elements of A. There are 3 diagonal elements. We have to calculate the minors of each of these diagonal elements. ठीक है? 3 diagonal element है, वो तीनों diagonal element का हमें minor निकालना है. अगर हमें minor निकालना है 8 का, suppose you want to calculate the minor of the diagonal element 8. 8 is there in the first row and first column. So leave out first row and first column. What remains? That determinant has to be calculated. Okay? So when we have to calculate the minor of the first diagonal element, the first diagonal element is in the first row and first column. तो हमें ये रो छोड़ना है और ये कॉलम छोड़ना है. Remaining determinant. So it will be equal to, we are leaving out, जहां पर भी 8 है वो 8 का कॉलम और रो हमको एलिमिनेट करना है. बाकी जितने एलिमेंट्स हैं उसका डिटर्मिनेंट निकालना है. So we have determinant of -3, -2, -4 and 1. And if I open this determinant, what will be the answer? Anybody? Determinant, everybody knows how to solve, right? So -3 into 1 minus of -4 into -2. तो क्या होगा आंसर?
-11.
कितना? -11, correct. Minor of the diagonal element 8 is -11. तो हमने क्या किया है? माइनर निकालने के लिए we have neglected the column and the row corresponding to that diagonal element. Now we have to calculate the minor of the second diagonal element, which is -3. So now minor of the diagonal element -3. -3 is there in the second column, second row. So leave out second column and second row. What remains? 8 -2, 3 and 1. Take the determinant of that. Okay? We have to leave the column and row corresponding to that particular element. -3 is there in the second row and second column. So leave out second row and second column. The remaining elements are 8 -2, 3 and 1. Calculate the determinant of this. So 8 plus 6. That becomes 14. Yes, 14, correct. फिर हमको निकालना है diagonal element, minor of the next diagonal element, which is equal to 1. Now again 1 is there in the third row and third column. So leave out third row and third column. The remaining determinants 8 -8, 4 and -3. Calculate that. Determinant of 8 -8, 4 and -3. And calculate the determinant of that. So 8 -8, 4 -3 कितना हो गया? Is it okay? 8 -24 plus 32. ठीक है, right है answer?
Yes.
Okay. Okay, fine. So 8 -8, 4 and -3. So now we have got the minus of the, so we are not using A minus lambda I determinant now. Okay? For a 3 by 3 matrix, we are calculating separately by using this formula. So first we have to write the diagonal elements and then write the minus of the diagonal elements, add all those. So now we will substitute a determinant of A. Now we have to calculate determinant of A. So what is determinant of A? You know how to calculate it, or you can use even calc to calculate the determinant. You know how to calculate by using calc? पता है कैसे निकालना है calc से determinant? Otherwise do it directly, manually you can do it. 8 into कैसे होगा? 8 into minus 3 into 1 minus of minus 4 into minus 2, then plus 8 into normal determinant, or you can use calc to calculate the determinant of any matrix. Just tell me the value of the determinant. आया किसी का आंसर determinant? If you want to use calc direct determinant, then you have to go to shift mode, use matrix, and then I'm not having a calc right, I'm not able to tell you exactly. Matrix we have to select, I think 1, 3 by 3, and then press AC, then again shift 4. पता है किसी को how do you calculate the determinant by using calc, or I'll tell you, you can follow those steps. 6, okay, 6 आ रहा है. What about others? 8 into minus 3 minus 8 plus 8 into 4 plus 6 minus 2 into minus 16 plus 9 equal to 6. Fine. Okay, you can also calculate determinant by using calc. Okay, this is 6. Now substitute everything in this formula. Lambda cube minus sum of the diagonal elements of A into lambda square plus sum of the minus of the diagonal elements of A into lambda minus determinant of A. Substitute किया तो क्या आएगा? Lambda cube minus sum of the diagonal elements 8 minus 3 plus 1 into lambda square. जितने भी minors निकालने, we have to add all those minus determinant of A equal to 0. ठीक है? Simplify 8 minus 3 plus 1, 9 minus 3, that is 6. Then simplify this also. So we will get the characteristic equation as lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. ठीक है? Just check the calculations also, okay? If I'm making any mistake, just let me know. Is this okay? 9 minus 3, that is 6. Then minus 11 plus 14, 3. 3 plus 8, that is 11 minus 6, yes. Now calculate the roots of this equation using calc. That you know, I think. You calculate the roots of this cubic equation using calc. Again, go to shift, mode, equation. I think the last equation in that, I think 4. 1, 2, 3, okay. We're just saying 1, 2, 3 here in A division. What about B division? Okay, Nitesh also got 1, 2, 3. Use calc, okay? Go to shift, mode, then equation, and that's the last one, I think. Last hai shayad, I think 1, 3, 2. Okay, whatever. The order is immaterial. You can write the eigenvalues in any of the order. Okay. So the values are 1, 2, and 3. The eigenvalues are now 1, 2, and 3. Okay, again I'm repeating, this formula is applied only when we have a matrix of order 3 or when we have a 3 by 3 matrix. Okay, in all the other cases, we have to calculate determinant of A minus lambda I equal to 0. ठीक है. Instead of expanding that determinant, you can directly calculate the sum of the minors and then add all these things. And determinant can also be calculated using calculus, so you can get the characteristic equation easily. So lambda equal to 1, 2, 3. ठीक है. Okay. Now we have got the eigenvalues. Corresponding to these eigenvalues, we have to calculate the eigenvector. Corresponding to this eigenvalue, now there are 3 eigenvalues. So for each of these eigenvalues, we have to calculate the eigenvector. तो यहाँ तक सबका हो गया. Can I move to next slide? पहले हमने मैट्रिक्स A लिखा है, फॉर्मूला यूज किया है, कैरेक्टरिस्टिक इक्वेशन निकाला है एंड द रूट्स ऑफ दैट इक्वेशन. Okay, so I'll move to the next slide to calculate the eigenvector. Okay, so we'll calculate the eigenvector. To calculate the eigenvector, we have to write the matrix A minus lambda I into X equal to 0. Okay, we have already formed the matrix A minus lambda I in the beginning. तो वही मैट्रिक्स यहाँ पे लिखना है और कैपिटल X के बदले x1, x2, x3 लिखना है. ओके, तो नाउ A minus lambda I into X equal to 0, हमें X निकालना है. That X is called as the eigenvector. तो हम क्या करेंगे, पहले A minus lambda I लिखेंगे जो हमने पहले निकाला था फर्स्ट स्टेप में. X के बदले x1, x2, x3 लिखेंगे, 0 के बदले 0, 0. We are converting this in the form of a matrix. I told you X is a non-zero column matrix. This is a column matrix. I'm naming it as x1, x2, x3 because these values are not known to us. Our aim is to calculate these values. ठीक है? So to find the eigenvector, determine A minus lambda I into X equal to 0. A minus lambda I लिखा है, X के बदले x1, x2, x3 and 0 के बदले 0, 0, 0. Now there are 3 eigenvalues. There will be 3 different cases. Case 1 will be when lambda equal to 1. Case 1 will be when lambda equal to 1. Now substitute lambda equal to 1 in this matrix. Put lambda equal to 1 यहाँ पे. तो lambda के बदले हर जगह 1 put करना है. So we will have the matrix as 8 minus 1 minus 8 minus 2 4 minus 3 minus 1 minus 2 3 minus 4 1 minus 1 x1 x2 x3 equal to 0 0 0. ठीक है? सबसे पहले हमने डिटर्मिनेंट निकाला था, अभी हमको मैट्रिक्स लिखना है यहाँ पे. डिटर्मिनेंट मैट्रिक्स ऑफ A minus lambda into X. There are 3 eigenvalues, so there will be 3 cases. Here we are calculating the eigenvector for case 1, that is when lambda equal to 1. Again simplify here, lambda के बदले 1 put किया है. Now simplify this, so we will have 7 minus 8 minus 2 4 minus 4 minus 2 3 minus 4 0 x1 x2 x3 equal to 0 0 0. Please write your attendance in the chat box, okay, so that I can take those attendance from the chat box. Okay, please do that, whoever is present. Okay, so what we have done, we have calculated this matrix, put lambda equal to 1 and got this. Now we are having this in the form of a matrix. Now again multiply these two. What will happen when we multiply these two? We will have first row, first column. अगर इसको multiply करना है तो we will get an equation 7x1 minus 8x2 minus 2x3 equal to 0. तो हमें ये matrix को equation में convert करना है. So we will have the first equation as 7x1 minus 8x2 minus 2x3 equal to 0. First equation. ठीक है? Second equation में 4x1 minus 4x2 minus 2x3. The second equation. 4x1 minus 4x2 minus 2x3 equal to 0. Third equation. 3x1 minus 4x2 plus 0x3 equal to 0. Okay, अभी तक क्या किया, clear है? We are forming the matrix A minus lambda into X, putting lambda equal to 1 in the first case, and then rewriting this matrix in the form of an equation. So we will get 3 equations. Our aim is to get the values of x1, x2, x3. So what we have to do is take any two equations. Take any two equations. जो equations तुम्हें select करना है, select करो. So I am considering first and second. You can choose 1 and 3 or 2 and 3 also. Everything will get the same answer. Don't worry about that. So I am taking equations 1 and 2. तो मैंने equation, any two equations लेना है, उसमें से मैंने equation 1 और 2 लिया है. So I'm rewriting the equations 1 and 2 again. Okay, you can use any two equations, either 1, 3, 2, 3 or 1 and 2. So I am using 1 and 2. कोई भी ले लो, answer same आएगा सबसे. Now we are going to apply Cramer's rule. Cramer's rule. You must have done this also. Cramer's rule. तो क्या करना है Cramer's rule में? Okay. Now there are two equations. ठीक है? तो हमें क्या करना है? ऊपर लिखना है using Cramer's rule. ऊपर आएगा x1 डिवाइडेड बाय x1 को छोड़ना है, बाकी जो भी कोएफिशिएंट्स है उसको नीचे लिखना है. ओके, देयर आर थ्री वेरिएबल्स x1, x2, x3. तो पहला हम लोग लेंगे x1. x1 मतलब x1 वाला कोएफिशिएंट छोड़ना है हमको, और x2 और x3 के कोएफिशिएंट्स का हमें डिटरमिनेंट निकालना है. तो -8, -2, -4 एंड -2. फिर उसके बाद सेकेंड हमको x2 निकालना है. जब x2 निकालना है तो x2 को छोड़ना है और बाकी के डिटरमिनेंट्स हमको लिखने हैं, बाकी के कोएफिशिएंट्स के डिटरमिनेंट्स हमको लिखने हैं. बट हियर वी हैव a sign minus, just like we have a sign for determinant. The second term is always negative in the determinant also. The same way we are having this minus sign here. ठीक है, तो बाकी के कोएफिशिएंट्स 7, -2, 4 and -2. Similarly, x3 will be leave out x3 and the remaining coefficients 7, -8, 4 and -4. Clear? Any doubt up till now? सबसे पहले हमने ये मैट्रिक्स लिखा है, लैम्डा को 1 पुट किया है, then rewritten this matrix form in the form of an equation. Considering any two equations, I have taken 1 and 2, and then we are using the Cramer's rule. Now simplify this again, determinant in the denominator, x1 upon, you will get some value. तो कितना होता है x1 upon 16 minus 8, correct? 16 minus 8 equal to minus x2 upon minus 14 plus 8 equal to x3 upon minus 28 plus 32. Again we can simplify. 16 minus 8 is 8, minus 14 plus 8, simplify everything. So we will have x1 upon कितना आएगा simplification, minus x2 upon minus 6 and x3 upon 4 equal to t ले लिया है. T can be anything. We can take it as t equal to 1 also. Can you cancel any common denominator? क्योंकि सब equal to है, so we can cancel 2 throughout. I think, and we can cancel 2 throughout the denominator. We can add x1 by 4, x2 by 3, x3 by 2 equal to t. So the first eigenvector will be corresponding to lambda equal to 1 will be x1, capital X1 equal to 4, 3, 2. Okay, तो हमने स्टार्ट कैसे किया है, a minus lambda into x से स्टार्ट किया है, उसमें से lambda के बदले फर्स्ट आइगन वैल्यू सब्स्टिट्यूट की है. We got a matrix, converted the matrix to equation, considering any two equations, and using the Cramer's rule we are calculating the eigenvector. Sorry, these are eigen, ये vector है, not values. Okay, hence the eigenvector corresponding to lambda equal to 1. ये values नहीं, please change that. ठीक है, now हमारे पास 3 है ना, तो take the next eigen value now, case 2. same method से करना है. case 2 में take lambda equal to 2. everything is same, खाली lambda के बदले 2 होगा, फिर से मैट्रिक्स फॉर्म होगा, मैट्रिक्स को इक्वेशन में कन्वर्ट करना है. Take any two equations, use Cramer's rule and calculate the second eigenvector. Try that. I'll repeat again. So, yeah. Slide number 8. Okay, fine. Yeah. Any doubt in this or anything is wrong?
For x2, you have taken the minus sign. For x3, minus, for XC also minus 7 will be there, na?
No. See, in determinant, when we simplify, what you do, the first element is positive, second element is negative, we take, right?
Yeah.
Third element is also again positive. When you open a determinant, you will take first element, then second जो रहता है negative रहता है, उसके बाद then third element is the same concept is used here also. Got it? तो alternate आएगा, पहला positive, second negative, third positive. नहीं तो क्या होगा, हमें उल्टा करना पड़ेगा यहाँ पे, -8 ऐसा करना पड़ेगा. That's why we are just doing it in the opposite direction. Clear? Anything else? B division, if you have any doubt, please unmute yourself and ask. कुछ और डाउट है तो पूछो, बिकॉज हाँ हाँ ठीक है. क्रेमर्स रूल कैसे करना है, दो इक्वेशन ले लिए हमने, कोई भी दो इक्वेशंस लेना है तो मैंने फर्स्ट और सेकंड लिया है, ठीक है. अगर हमको x1 निकालना है तो x1 का जो उसको एलिमिनेट करना है, उसको नहीं कंसिडर करना है. लीव दिस x1 फ्रॉम दीज टू इक्वेशंस. तो क्या बचता है, x2 और x3 बचता है. उसका कोएफिशिएंट्स कौन कौन से हैं, -8, -2, -4, -2. तो मैंने यहाँ पे लिखा -8, -2, -4 एंड -2. ठीक है. अभी हमको x2 करना है, तो x2 is this is actually by the determinant का properties, this element becomes negative. So if I take x2, leave out this x2 वाला variable, take only x1 and x3. x1 और x3 के जो कोएफिशिएंट्स हैं उसको नीचे लिखना है हमको, 7, -2, 4 एंड -2. फिर हमको x3 लेना है, तो x3 को हमें एलिमिनेट करना है. तो वी डोंट कंसिडर x3 वेरिएबल, वी विल टेक ओनली x1 एंड x2 वेरिएबल, और x1 x2 की जो कोएफिशिएंट्स है उसको लेना है हमको यहाँ पे. तो 7, -8, 4 एंड -4. क्लियर है अभी कि और स्टिल यू वांट मी टू एक्सप्लेन मोर? क्लियर है. ठीक है. जब x1 लेते हैं तो x1 को छोड़ देना है, x2 x3 के कोएफिशिएंट्स को लेना है. जब x2 लेंगे तो x1 और x3 के कोएफिशिएंट्स को लेना है, और जब x3 लेंगे तो x1 और x2 के कोएफिशिएंट्स को लेना है. बट ओनली थिंग वी हैव ए नेगेटिव साइन इन x2. दैट इज बाय द प्रॉपर्टीज ऑफ डिटर्मिनेंट, वी हैव फ्रॉम देयर वी हैव दैट नेगेटिव साइन. Then the normal simplification of this determinants, and then simplifying and calculate. We are simplifying. 16 minus 8 is 8, minus 14 plus 8 is 6, and minus 28 plus 32. We are simplifying that and writing it in the next. So can I go to the next slide now? Any other doubt in this slide to calculate the eigenvector? Because the whole chapter deals with eigenvalues and eigenvectors only. So we should be very... Okay. So I'll go to the next slide. उसको सिंप्लीफाई करके यहाँ पे लिखा हुआ है, और यहाँ पे भी 8 - 6 4 में भी 2 कॉमन है, तो मैंने 2 कैंसिल कर दिया है. तो I've got 4, 3 and 2. So the first eigenvector corresponding to, this is not value, this is vector. Okay, just change this part. This is vector corresponding to lambda equal to 1 is x1 equal to. Next, go to case 2. Case 2 is lambda equal to 2. ठीक है. फिर से हमें a minus lambda I में lambda equal to 2 पुट करना है. हमारे पास ऑलरेडी a minus lambda I x वेक्टर था, तो वहां पे lambda के बदले, पहले हमने lambda के बदले 1 पुट किया, now lambda के बदले 2 पुट करना है. Whatever we have done, that has to be continued. फिर से इसको सिंप्लीफाई करके मैट्रिक्स के फॉर्म में लिखना है, मैट्रिक्स के फॉर्म को फिर से इक्वेशन के फॉर्म में लिखना है, एंड फ्रॉम इक्वेशन वी आर कैलकुलेटिंग द वैल्यूज ऑफ x1, x2, x3. Again, once you get the matrix, write the equations corresponding to these matrices. We have 6x1 minus 8x2 minus 2x3 equal to 0. Equation 1. Second row, 4x1 minus 5x2 minus 2x3 equal to 0. Third, 3x1 minus 4x2 minus x3 equal to 0. Okay. Okay, you can just try solving these three equations simultaneously using calc. Let's see what answer we get. Just try solving these three equations simultaneously.
मैम इनफाइनाइट सॉल्यूशन आ रहा है.
हाँ, that is why we are taking any two. We get only one of, because when taking equal to t, na, we'll get only one of the solution. When t is equal to 1, we get one of the solutions. We have infinitely many solutions. Like when t is equal to 2, you will get the second solution. That is why we cannot solve all the three using calculus. So we are making use of Cramer's rule. है ना? So now, considering equation, again you can take any two. I'm considering 1 and 2. So again use Cramer's rule. Try yourself. x1 upon क्या आएगा determinant नीचे. अगर हमें x1 upon लिखना है तो x1 को छोड़ना है. x2 और x3 के कोएफिशिएंट का डिटर्मिनेंट बनाना है हमको. ओके, तो इट विल बी x1 upon डिटर्मिनेंट क्या होगा, -8 -2 -5 -2. x1 को हमने छोड़ा है, x2 और x3 के कोएफिशिएंट्स को हमने यहाँ पे लिखा है. नेक्स्ट हमें x2 निकालना है. x2 के साथ एक माइनस साइन आता है न्यूमरेटर में, और x2 को छोड़ना है, x1 और x3 के कोएफिशिएंट्स को नीचे लिखना है. तो वी हैव नाउ -x2 upon 6 -2 4 and -2. फिर इक्वल टू x3 अपॉन x3 को छोड़ना है, x1 और x2 के कोएफिशिएंट को लिखना है. ठीक है. Simplify the determinants in the denominator and tell me what will be the second eigenvector. See, all these so many steps you can neglect that. I have written everything in detail. That many steps are not required. ठीक है. तो what are the values? x1 x2 x3 क्या आ रहा है, second eigenvector. You can cancel out the common, if you have any common terms in the denominator, you can cancel that after simplifying the determinant. -3, okay, -3 -2 and 1. Uttara is getting 3 2 and 1. Okay, 3 2 and 1. Okay, what about b division? Remember, you have minus sign in the numerator for x2 also. You have to consider that minus sign also. Okay, 3 2 1 ही है समीर का भी. Okay, what about division b? आया किसी को आंसर इसका? To simplify, they will get x1 upon 6 minus x2 upon -4 and x3 upon 2. We can cancel 1 2 throughout, and these x2 are here also negative, here also negative, so everything will become positive. So we can get the, yes, x2 3 2 1 is right. 3 2 1. I took it. No, you will get the same answer. Just check that. You will get the same answer. -2 क्यों आया? I think because you have not taken the numerator का minus. I feel that you have not taken the numerator का minus, है ना? Same आएगा. कोई भी equation लो, answer will be the same. I am showing 1 and 2. You can take any two equations. Don't. I answer. Prathamesh, just check your answer also. Sheetal, you got, no? Prathamesh also. Okay. B division, all of you getting the same answer? 3 2 1. Not able to log in through two Google Meets using mobile. That is a problem. Otherwise, I would have. ठीक है. Case 3 पे जाते हैं. Again, eigen vector है. मेरे हर जगह eigen value लिखा हुआ है. Just change that. Lambda equal to 2 का हो जाएगा 3 2 1. Next case 3. Lambda equal to 3. Lambda के बदले 3 पुट करना है. So try this. Let's see what answers you get for the third eigenvector. the eigenvector of the third eigenvalue. Put lambda equal to 3, you will get a matrix. Convert the matrix to equations. Take any two equations and calculate the values of x1, x2, x3. You cannot solve all the three. You will not get an answer using calci. That is why we have to apply Cramer's rule. So when I put lambda equal to 3, 8 minus 3 यहाँ पे 5 हो जाएगा, यहाँ पे -3 and 1 minus 3. Putting lambda equal to 3. So 5 minus 8 minus 2, 4 minus 6 minus 2, 3 minus 4 minus 2, x1, x2, x3 equal to 0, 0, 0. Write the equations corresponding to this. Even if you don't write the equations, fine. You can calculate from here also. Take first two row, leave out the first row, take the determinants of the remaining. That also can be done directly also, no problem. But normally हम लोग solve equations से करते हैं. That is why. But you can do it directly also from here. First two rows लेना है, first को छोड़ना है, बाकी दोनों का determinant. Second में second को छोड़ना है, first और third का determinant. So we have three equations. Take any two equations again, use Cramer's rule and calculate. But suppose you are getting two similar equations, then you should not consider those two equations. दोनों equations अलग होना चाहिए. नहीं तो you will get 0, 0, 0 as the eigenvector, which is not possible. तो इतना ध्यान देना है कि when you have two, suppose you have two similar equations, then you cannot consider two similar equations. Okay, दोनों different, अलग अलग होने चाहिए. यहाँ पे think all the three are different, so you can take any two equations. But suppose you have, I've got problems of that type also. I'll show you that. So when you have a similar equations, then don't use, you cannot take those two equations. When you have two different equations, then apply that. ठीक है, कौन से ले रहे हैं फर्स्ट एंड सेकंड? मैंने तो फर्स्ट एंड सेकंड लिया है. You can take any two. 2, 1, 1. Okay. B division. चैट देखना पड़ेगा लगता है मुझे. 1 second. Again 1 and 2, use Cramer's rule. 2, 1, 1. Yes. So all of you are getting. B का मुझे कुछ पता नहीं चल रहा है. B division, are you there? B division, please write your attendance in the chat box. 2, 1, 1. That's right. Again, x1 निकालना है तो x1 वाला x1 वेरिएबल छोड़ना है, बाकी दो वेरिएबल्स के कोएफिशिएंट्स को नीचे लिखना है. Similarly, minus x2 upon, leave out this x2 variable, x1, x3 coefficients, and similarly x3 one. Simplifying the determinant. Four minus 2, so we can cancel 2 throughout. We will get 2, 1, 1. So lambda equal to 1 is 2, 1, 1. So we have three eigenvectors corresponding to three eigenvalues: 4, 3, 2, 3, 2, 1, and 2, 1, 1. Any doubt? Division B. I'm seeing your chats now. Okay, I've got 211. Yes, correct. Sarvagya, which slide? Is it okay? Clear, all of you? Any doubt? You can take one more problem, maybe. Same type. You can try this. So again, eigenvalues and eigenvectors of the matrix 2 minus 3 1 3 1 3 minus 5 2 minus 4. So first our aim is to form the characteristic equation, find the roots of those characteristic equation. Those roots are called as the eigenvalues, and then we have to find the eigenvector. So again, we are given a 3 by 3 matrix, so we can use the formula to calculate the eigenvalues or the characteristic equation. But before that, you form the matrix A minus lambda I. So let us take the given matrix as A, calculating A minus lambda I. You can write all these steps can be written directly also, because I have just shown all these things in PPT. But in the exam, you can write directly A minus lambda I. क्या करना है? जो भी diagonal element है, उसमें lambda को subtract करना है हर एक diagonal element से. So 2 minus lambda, 1 minus lambda, minus 4 minus lambda. और कुछ नहीं करना है. You need not show these steps. Directly also you can write A minus lambda I. तो हमें क्या निकालना है? Determinant of A minus lambda I. Again, since we are given a 3 by 3 matrix, we can calculate the characteristic equation using the formula. Formula में we require the minors of each of the diagonal elements and the determinant of A. This is not, this is directly. So we'll calculate the characteristic equation using this formula. So just tell me what will be the minor of the diagonal element 2. What will be the minor of the first diagonal element 2? 2 कौन सी पोजीशन पे है? फर्स्ट रो फर्स्ट कॉलम. तो हमें फर्स्ट रो छोड़ना है, फर्स्ट कॉलम छोड़ना है, द रिमेनिंग डिटर्मिनेंट. What is the value? Minus 10. Okay. That is minus 10. Similarly, minor of the diagonal element, second diagonal element 1. तो second diagonal element कहाँ पे है? Second row, second column. तो हमको second row और second column छोड़ना है, बाकी का determinant निकालना है. Calculate the minor of the diagonal element 1. So it is going to be the determinant of 2, 1, minus 5, minus 4. तो क्या आएगा आंसर? If you make mistake in this minor, everything will go wrong because the equation will be wrong and accordingly the roots also will be wrong. So very carefully you have to write these minors. Minus 3, okay? Okay. Let's see the answer. So minus 8 plus 5, which is minus 3. Similarly, again, all these steps are not required. You can directly write it over here also. मैंने यहाँ पे दिखाया ताकि समझ में आ जाए करके. Minus 4 का क्या होगा? Now minus 4 is there in the third row, third column. So leave out third column and third row, the remaining determinant. So 2 minus 3, 3 and 1. Minus 7 किसका आया प्रणाली? You have got minus 7. No. Okay. 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 तो कितना हो गया? 2. 8 कैसे? किसका 8 आया? 1 second. Am I wrong then here? 2 minus 3, 3 and 1. No? So 2 plus 9. 11 right है ना? हाँ. 8 किसका आंसर था ये वाला? Nitesh, Anisha and all of you written 8, 8. Is it okay? 11 is right ना? ठीक है. अभी डिटर्मिनेंट निकालना है. हाउ यू कैन डिटर्मिनेंट डायरेक्टली निकाल रहे हो कि कैलसी से निकाल रहे हो? क्या कर रहे हो? 11 is correct. Yes. How are you calculating the determinant? Either by calci or you doing it manually? Calci से आता है करना? You know how to calculate the determinant using calci? Calculator से कर रहे हो? Okay, fine. Okay. Because we have to multiply matrix and all, you can use calci and check your, but the steps are required. Otherwise, you can calculate the values using the calci. Determinant of A. कितना है determinant of A? Characteristic equation has to be perfect. Then everything will be right. Once you make mistakes in writing the characteristic equation, then eigenvalues will be wrong, and once the eigenvalues are wrong, eigenvectors also will be wrong. So you have to check the characteristic equation. That is very important. ठीक है? You can complete this. Is it 0? Yes. Substitute everything. Sum of the diagonal elements. So 2 plus 1 minus 4. और फिर ये तीनों का sum. Minus 10, minus 3, plus 11. Determinant is 0. So what are the eigenvalues? Determinant is 0. Calculate the eigenvalues. One minus 2, 0. Okay. Okay, 1 minus 2, 0. Okay. The remaining part you can try when lambda equal to 1. What is the eigenvector? Then lambda equal to minus 2, what is the eigenvector? There will be 3 eigenvectors. We'll continue the next lecture because it's almost time. You have next lecture. कुछ doubt है इसमें? Anybody having any doubt in calculating the eigenvalues and eigenvectors? Division B, okay. So Rojit has got 1 minus 2, 0. Harsh, what is minus 1 you have got? डिटर्मिनेंट की वैल्यू है क्या? या वेदिका, व्हाट इज योर? One minus 2. Hope all of you have written your attendance in the chat box. No doubts? Okay. We'll continue with this. Now we have repeated roots, how to find eigenvector. We have different types of eigenvalues and eigenvectors. We'll do that in the next lecture. Okay, if you have any doubt, you can ask. Otherwise, you can leave. See, I just want to know one more thing. This is better, or should I use my perfectus? What do you feel? This is better right now. Even I don't like the my perfectus part. That is what I thought. I will prepare 2 different meats. I think it's working. I think it's not. This is good, na? ठीक है. Meat is better, na? Okay. So you may have to adjust it sometimes because I may not be able to see both the chats together. Okay, just you have to little bit cooperate with me. Thank you so much. We'll see you in the next lecture. Continue in the next lecture. Please don't forget to write your attendance in the chat box. Bye, bye, bye. Before leaving, please write down your attendance because I'm not having the meet attendance here. So please write down. Don't forget to write your attendance. Division A, Division B, both. So that I can